Good night, I am Kristonie and I will be presenting this basic home lab about limiting reactants. So first off, we have baking soda in these balloons here, these balloons, and that is called sodium bicarbonate, and the vinegar in the balls is the acetic acid. So the sodium bicarbonate reacts with the acetic acid to form sodium acetate and carbonic acid, and that is called a double displacement reaction. After that, the carbonic acid is not very stable, so it goes through a decomposition reaction to produce carbon dioxide and water. So the general balance equation is the sodium bicarbonate reacts with the acetic acid to form sodium acetate, carbon dioxide, CO2, and water, which is H2O. So the general purpose of this lab is to determine which is the limiting reactant or reagent. If it's the sodium bicarbonate, which is the baking soda, or the acetic acid, which is the vinegar. And the definition of a limiting reactant is a chemical reactant that limits the amount of product that is formed in the product. So first here we have 100 ml of acetic acid, which is the vinegar, in all of the 1, 2, 3, 4 bottles. And label here we have balloon 1, which contains 1/4 teaspoon of sodium bicarbonate. Balloon 2, which contains 3/4 sodium bicarbonate. Balloon 3, which contains 1 teaspoon and a half teaspoon of sodium bicarbonate. And lastly, we have balloon 4 that contains 3 whole teaspoons of sodium bicarbonate. Okay, so let's put in the number 1 balloon that has in 1/4 sodium bicarbonate. Let's react it with the vinegar. Let's wait a little. Let's react number 2 balloon that contains 3/4 of sodium bicarbonate. Okay, so let's react the balloon 3 with 1 teaspoon and a half sodium bicarbonate. You can see this one is rapidly increasing in size when it comes to the reaction. there's a bit of liquid in there. And now we're at the 3 teaspoons of sodium bicarbonate. You can see this is the balloon is expanding rapidly. Some liquid is in there as well. So let's have a closer look here. Number 1 is much smaller than number 2, and all is dissolved here, and 3 and 4 is basically the same in volume. 3 looks smaller than 4, but they're basically the same. So number 1 and 2, the baking soda, is the limiting reactant, because as you can see, the baking soda limits the product formed, because the baking soda moles is much smaller than the acetic acid, and 3 and 4 is basically the same in volume. So the acetic acid is the limiting reactant because it limits the amount of carbon dioxide produced. Hence the reason the balloons couldn't expand much larger, because the amount of vinegar that was here wasn't enough for the amount of baking soda that was put in the balloon and reacted. 3 and 4, the maximum carbon dioxide was produced, and 1 and 2, the baking soda limited the carbon dioxide produced, and we left it for a while, so some of the carbon dioxide escaped. But here's the experiment, more or less. Let's say we have a 5th and 6th balloon. The same 100 ml vinegar will be used in the bottle, but 6 teaspoons of baking soda will be used. In this reaction, the vinegar will be the limiting reactant, because the vinegar moles is much smaller than the 6 teaspoons of baking soda. So hence the reason the amount of vinegar will not be enough for the 6 teaspoons to fully react and make the full products. So the amount of carbon dioxide will be limited. Let's say we have a 6th reaction, and this will contain 3 teaspoons of baking soda and 200 ml of vinegar. This reaction will take place, and the limiting reactant will be the baking soda, because the 3 teaspoons of baking soda is much smaller in moles than the large 200 ml vinegar. So that will limit the amount of carbon dioxide that will be produced, because the 3 teaspoons of baking soda will not be enough to form the full carbon dioxide capacity that the balloon can hold, and hence the reason the baking soda is the limiting reactant. Good night. Now I will explain the calculations. So first we have 1/4 teaspoon of baking soda is an estimated 1.25 grams. If this reacts with 100 grams of vinegar, how much moles of carbon dioxide can be produced? So first we have to set up the dimensions analysis. So we have here the baking soda, which is the sodium bicarbonate, and then we have 1.25 grams of sodium bicarbonate times 1 mole of sodium bicarbonate over 84.01 grams/mole sodium bicarbonate. And then the grams and grams of sodium bicarbonate cross out, and then when multiplied and divided gives you 0.0149 moles of sodium bicarbonate, which is the limiting reactant, which we will get to very shortly, wise it's the limiting reactant or reagent. Now we have the acetic acid, which is the vinegar. We will set up the dimensions analysis. 100 grams of acetic acid times 1 mole of acetic acid over 60.05 grams per mole of acetic acid. Then the grams per mole cross out. Then when multiplied and divided, give you 1.67 moles of acetic acid or vinegar. Then now we need to find out how much moles of carbon dioxide can be produced. So we have here the sodium bicarbonate mole, which is 0.0149 mole of sodium bicarbonate, then times that by the 1 mole of carbon dioxide over 1 mole of sodium bicarbonate. This is the 1-to-1 ratio. This gives you 0.0149 mole of CO2, which is the same as the moles of sodium bicarbonate here. Then we do the same for the acetic acid, 1.6652 mole of acetic acid times 1 mole of CO2 over 1 mole of acetic acid. The 2 moles of acetic acid cancel out. This gives you 1.67 moles of CO2, which is carbon dioxide. The limiting reagent, the moles of the sodium bicarbonate is much smaller than the moles of acetic acid. So in this proposed reaction, the sodium bicarbonate will run out or finish faster in this chemical reaction. This is the limiting reactant, and the definition of limiting reactant is the reactant that limits the amount of products that is formed. So this is the sodium bicarbonate in this case, limits the amount of carbon dioxide that is formed. And number 2, we have here a 10-gram sample of sodium bicarbonate was reacted with excess acetic acid. 111.88 grams of carbon dioxide was collected. Calculate the theoretical yield for this reaction. First, we have to set up 10 grams of sodium bicarbonate times 1 mole of sodium bicarbonate over 84.01 grams of sodium bicarbonate times 1 mole of carbon dioxide over 1 mole of sodium bicarbonate times 4401 grams of CO2 over 1 mole of CO2. So we have here the grams of sodium bicarbonate cancel out, the moles of sodium bicarbonate cancel out, and in this dimension analysis, we need to put the units that we want to cancel out across from each other. So hence the reason these cancel out. And then the mole of CO2 and the mole of CO2 cancel out. So when you multiply across and divide, you get 5.24 grams of carbon dioxide for a theoretical yield. And that's it for its calculations.